Good morning, class. We are looking at Chapter 2, Limits, Section 2.4, Limits, Algebraic Methods. So we've looked at limits of sequences, limits of functions at infinity, limits of functions at finite numbers, and now algebraic method. Recall. Limits of functions at finite numbers, finding limits by numerical and graphical methods. When we look at this, we read it as the limit of f of x as x approaches a equals L. Now, for the sequences that we discussed and we studied, the limit of a sub n as n approaches infinity is L. We say that a sub n converges to L. If this limit is infinity, negative infinity, or does not exist, we say the sequence diverges. To find limits, simply plug in and observe. If we are interested in finding the limit of f of x as x approaches a, for all of these graphs, as we approach a from the left and right, from the left we are in this branch, from the right we are in this branch. So from the left we approach L from the bottom, and in this branch from the top, in which case the limit of f of x as x approaches a equals L for each and every one of them. What's the difference? In this case, f of a is also L. That makes it continuous. In this case, f of a is b. In this case, f of a is not even defined. Horizontal asymptote, or HA, the limit of f of x as x approaches negative or positive infinity is L, gives rise to the equation of a horizontal asymptote y equals L. Vertical asymptote, short VA, limit of f of x as x approaches a, or a from the left or right, is either negative or positive infinity. One-sided limits. A function has a limit at a if the limit of f of x as x approaches a from the left or right is L, which means the limits on each side must be identical, one-sided limits. And now 2.4, limits, algebraic limits, limit laws. Let f of x and g of x be defined for all x over some open interval containing a. Assume L and M are real numbers such that the limit of f of x as x approaches a is L, the limit of g of x as x approaches a is M. Let C be a constant, some number. And then each of the following statements holds. This is known as the sum law for limits. The limit of f of x plus g of x as x approaches a is limit of f of x as x approaches a plus limit of g of x as x approaches a, which is L plus M, meaning the limit of the sum is the sum of the limits. The rest of them follow in the same manner. The limit of the difference is the difference of the limits, L minus M. The limit of a constant multiple. If you have a constant times f of x, you can take the c out, and it becomes c limit of f of x as x approaches a, or c times L. The product law. The limit of the product is the product of the limits, L times M. The quotient law. The limit of the quotient is the quotient of the limits, L over M. As always, the denominator, in this case M, can't be 0. The power rule, the limit of f of x to the power of n as x approaches a is limit of f of x as x approaches a. Then you raise it to the power of n, becomes L to the power of n for positive integers, and the roots also work out in the same manner. As far as the roots are concerned, when in n the index is odd, there is no limitations. If if n the index is even, then L must be non-negative, greater than or equal to 0. If k is a constant, is some number, the limit of k as x approaches a is k. In other words, this is independent of x. So if you have a number, the limit is itself. And finally, direct substitution, as we've already discussed, that a continuous function at A has the following limit, the limit of f of x as x approaches A equals f of A. So this is the synopsis of what we are going to use. And we start with the warm-up example. We want to use limit properties or limit laws to find this limit of x squared minus 3x plus 7 as x approaches 4. Number one, we use the limit laws to cut this into three limits. Limit of x squared as x approaches 4 plus limit of minus 3x as x approaches 4. And finally, the limit of 7 as x approaches 4. This one, according to the limit laws, limit of x as x approaches 4 to the power of 4, this one, negative 3 comes out. And now we are ready to plug in. This becomes 4, this becomes minus 3 times 4, and this is the constant. 16 minus 12 is 4, plus 7 is 11. And as I mentioned, you can simply plug in. So you get this one in essence. 4 squared minus 3 times 4 plus 7, which is 11. Evaluate the following limits if they exist. The limit of f of x plus 5 g of x as x approaches negative 2. We are looking at the graph, and definitely we have to use the limit laws. We cut this into two pieces. Limit of this piece plus 5, the limit of this piece as x approaches negative 2. For this one, well, first and foremost, this is 0, 1, 2, 3, 4. This is negative 1, negative 2, negative 3, negative 4. So this is negative 2. As we want to find this, we're going to look at each piece, limit of f of x as x approaches negative 2. So we are approaching negative 2 from the left and right. And for the red function, f of x, also from the left and right, it moves us towards this point, which has a y-coordinate 1. Let's look at limit of g of x as x approaches negative 2, the blue function. And as we move from the left and right, we are moving towards this point, and this point has a y-coordinate of negative 1. So we have 1 plus 5 times negative 1, they add up to negative 4. The limit of f of x times g of x as x approaches 1. Let's use the limit laws, cut them into two pieces. So the limit of the product is the product of the limits. And let's look at each piece. So limit of f of x as x approaches 1. Here's number 1 along the x-axis. As we get closer and closer to 1 from both sides, for the red function, we get closer and closer to this point, and this point has a y-coordinate, which is positive 2. Let's look at the limit of g of x as x approaches 1, and that one does not exist. DNE does not exist. Why is that? Well, as we approach 1 from the left, we are in this branch moving us towards this point, which has the y-coordinate negative 2. As we approach 1 from the right, we are in this branch moving us towards this pole, which has a y-coordinate negative 1. Since the two are different, the limit of g of x as x approaches 1 does not exist. Therefore, this doesn't exist. The limit of the product doesn't exist. The limit of the sum doesn't exist. None of the above. We are just interested in the product anyways. There's a second method, and that is to go back to this and try to find it in this fashion from the left and right. So this one, so this piece from the left and right, it doesn't matter, it's 2. This one from the left is -2, and it becomes 2 times -2, which is -4. Now go back to this one now from the right. So this was the limit as x approaches 1 from the left. Now 1 from the right, it doesn't matter for this function, left and right is the same, but this function, the right is different. It's -1. The product of these two is -2, and they are not equal. So that's another way of approaching. Now, also, let's see what's the functional value f of -2. So the f function is the red function at -2. You look for a solid point. This solid point has a y coordinate 2. That's the functional value. G of 1 for this function, the blue function, at x equals 1, you look for a solid point. This is the point which is solid and has a y coordinate of -2. So g of 1 equals -2. The limit of absolute value of x over x as x approaches 0 does not exist. Why is that? It has got to do with one-sided limits. So first, let's remind everybody of the absolute value of x and the meaning of it. Absolute value of x is equals x if x is larger than or equal to 0, and negative x if x is less than 0. The meaning is, if x is not negative, just drop the absolute value. If x is negative, right, it's opposite. That's the meaning of it. So it's important to understand -x doesn't mean a negative value. And so for this function, because the denominator has x, we don't have the equality. We just have larger than 0. So larger than 0 becomes x over x, which is 1. Less than 0 becomes -x over x, which is -1. We have two different pieces. And if you were to look at the graph of the top piece, y equals 1 is a horizontal line. The bottom piece, y equals -1, is a horizontal line. However, this says x larger than 0, so this horizontal line just is good from 1 on and not at 1, and the left side is not good. That's a half line. Same thing for this one. When x is less than 0, it's good. That's also a half line. That is the graph, and the endpoints, both of them, are not included because we don't have the equality. And so if you look at the limit of this function as x approaches 0 from the left, that means you have to look at this bottom piece, and the answer is -1. However, the limit of absolute value of x over x as x approaches 0 from the right, you look at this piece, and the answer is 1. These two are different. One-sided limits must be identical for the limit to exist. They are not, so the limit of absolute value of x over x does not exist. The one-sided limits are not the same. We want to find the following limits, and basically we are going to plug in and observe. So if you plug in a 2 squared is 4. You get 2 times 4, 8 plus 1 is 9. This one is 3 times 2, minus 2 is 4. And square root of 9 over 4 equals 3 halves. In other words, you plug in, it works out, you're done. The limit of 1 over 4 plus 1 over x plus 4 as x approaches negative 4 is of interest to us. And if you plug in minus 4, I hope you realize that it's 0 over 0, and therefore it's what we call indeterminate. And indeterminate form, let's just write it down here so I can keep it. Indeterminate form requires your algebraic technique. And because this is a complex fraction, you need LCD, the least common denominator. There are two fractions at top. Their LCD is 4x. You're going to multiply by and divide by 4x. It's important to remember, x is approaching negative 4, making x plus 4 0. Therefore, you never ever distribute. Rather, you keep this as a product because you're hoping in the process you can get rid of the factor of x plus 4. So the bottom is the product of these two pieces. The top is 4x times 1 over 4, which is x. 1 over x times 4x, which is 4. And therefore, we can drop these two. We get the limit of 1 over 4x as x approaches negative 4. Plug in and we get negative 1 over 6. The limit of x squared minus 25 over x squared minus 5x as x approaches 5. If you plug in, you get 0 over 0. So you use your technique of factoring. And because x is approaching 5, creating a 0 in the denominator, we must have a factor of x minus 5. It's important to know if x is approaching 5, we should have a factor of x minus 5. If x is approaching, let's say, minus 2, then we should have a factor of x plus 2. Needless to say, we can easily factor the denominator as x times x minus 5. This is x squared minus 5 squared. That means a squared minus b squared, which is a minus b, a plus b. So we get x plus 5 times x minus 5 in the numerator. We drop the x minus 5 from the top and the bottom. Now, if you plug in 5, you get 10 over 5, which is equal to 2. All right. We have the limit of x squared minus 4x over x squared minus 3x minus 4 as x approaches 4. First thing first, we plug in, we get 0 over 0, which is an indeterminate form. X is approaching 4. That should help you. Because if x is approaching 4, that creating 0 in the denominator, you must have a factor of. Because of x approaching 4, you must have a factor of x minus 4. That will help you with the factoring in case anybody has any difficulty with the factoring. So the top is x times x minus 4. The bottom is x minus 4 times x plus 1. We drop the common factor of x minus 4, and if we plug in, we get 4 over 5. The limit of the square root of 1 plus h minus 1 over h as h approaches 0. Again, if you plug in, you get 0 over 0. And because the numerator is having a square root, you multiply by the conjugate, as you know, a minus b The conjugate is a plus b, resulting in a squared minus b squared. So the conjugate would be the same thing with the plus sign in between. You're going to multiply the top and the bottom by it because this expression must be equal to 1. You can't multiply by any other number. So the numerator becomes the square root of 1 plus h quantity squared minus 1 squared. The first piece comes out. The second piece is 1. 1 and negative 1 cancel each other. And again, these two cancel each other, and we get the limit of 1 over square root of 1 plus h plus 1. I want to go back, and again, I want to remind you, because h goes to 0, you never distribute. And now if you plug in, you get square root of 1, which is 1, 1 and 1 is 2, and the final answer is 1/2, everybody. That's pretty straightforward. The limit of square root of x squared plus 9 minus 5 over x plus 4 as x approaches -4. Clearly, you plug in, I mean, obviously the denominator is 0. What happens here, you get -4 quantity squared, 16 and 9, 25 comes out as 5 minus 5, also 0. And that's an indeterminate form. Because this involves a square root, then we multiply by the conjugate. That means we write the same thing. We just change this one to a plus. We multiply and divide because this fraction must be equal to 1. Again, the bottom, x plus 4 is a problem because it approaches 0. You never, ever distribute. You write them as a product. The numerator becomes a squared, the square root of x squared plus 9 squared minus b 5 squared, and this comes out as x squared plus 9. This becomes 25 minus 25. And again, I remind you that minus 5 quantity squared is 25, but minus 5 squared is minus 25. And so these two add up to -16. Clearly, the numerator is x squared minus 4 squared can be factored into x minus 4x plus 4. We can drop the common factor of x plus 4 from the top and the bottom. If we plug in now, the top becomes -4, the bottom becomes -4 quantity squared, and we've already shown that that is 16. 16 plus 9 is 25, and so the top becomes -8, the bottom becomes +10. The final answer is -4/5.